Alright, we have another video on functions here, this time on function transformations. So if I have a function, every function you know is divided into what's called a function family. And they're the basics that when you learn these in high school or grade school, they're the first ones you probably learn. The line y equals x, the parabola y equals x squared, or y equals x cubed, or whatever. Y equals the absolute value of x is another common function family. That's called the parent function. And I can take that. Any other graph that you have involving x squared is actually just y equals x squared moved somewhere else on the graph. So what does this mean? Well, this means that I can do a couple different things. I can move it up. So if this is y equals x squared, if I wanted to move this graph up 3 units, I would just pick points on the graph and I would just drag them up by 3. Okay, and then I would graph a new parabola using those points. And I'm actually going to give myself 2 more just because my drawing ability is not the best. And we would say to add 3 to each point, we would say that's y equals x squared plus 3. And that's called your vertical shift. And again, why is that plus 3 at the end? Because you do the x squared first. So, for example, with 0, you would say y equals 0 squared is 0 plus 3 gets us to 0, 3, where we moved that point to. Okay? What if I wanted to go down? Well, down, 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 down. Draw my new parabola. I move this down 2 units. This would be the function y equals x squared minus 2. Why? Think about the 0 again. I started at 0, 0. To move it down to negative 2, I subtracted 2 from the coordinate here in the y. All right? What if I want to go left or right? Well, that becomes a little bit more complicated. So with this one, I want to go left 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Graph my parabola. All right. For this one, I have to do, this is how I think about it. So when I did y equals 0 squared, I got 0, the point 0, 0. I want to have this, because I didn't move it up or down, I want to have the same y coordinate 0, but I need a new x. And I need it to have moved over to the left by 2. Okay, so y equals x minus my h, that's for horizontal shift, y equals x minus h squared. I know that I should have the 0 for my y, and I know that for this, well, let's think about this. I need it to go over 2 spaces to the left. Well, that leads me to believe that should be a 2, right? You would think. And, well, if I'm going to do this, and I want to know what I have that gives me that movement, I actually have to add. Why do I have to add 2? That doesn't make any sense. Well, because what's going to make this be a 0? What's going to make this be 0? Well, I need to have a situation where this gets me a 0. Well, that means that x minus 2 has to be 0. Or actually, maybe it'd be clear if I did it this way. I know that this is 2. This is negative 2. What's going to make that be 0? Why do I know that that x-coordinate has to be negative 2? Because that's what I saw when I moved it on the graph. Well, how do I get that? Well, let's solve it. Square root of both sides. I'm glad that I did it this way, because I hope this is a little bit more clear to you why I have to do the addition. Negative 2 equals negative h. I'm going to add 2 to each side. So I would get 2 equals negative h. Subtract 1, or sorry, divide by 1 on each side, I get h equals negative 2. So if my formula is y equals x minus h squared for a horizontal movement, I would take my value x minus negative 2 squared, and I know that double negative becomes positive. That's why I have to add when I move to the left. Because we know that when we move that 0, 0 over to the left, the new x-coordinate becomes negative 2, and I need to understand how that applies to everything in that function. So, now, why is it minus h in the first place? Well, quite simply because when you do this, think about how we had when we did lines and point slope. We always used minus, right? Y minus y1, x minus x1. We use the difference when we are going to be moving things around, with the exception of vertically, because when we're going in left or right movement, we have to apply our transformation before we do the main thing that the function does, in this case, squaring. And that means we have to do the opposite. So if you want to move right, you would subtract. If you want to move left, you would add. All right, let's look at another example, because I think that might still be, some of you are looking at your screens going, what is he talking about? Okay. Let's take y equals x squared to the right 1 unit. 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 Okay. So we've got, that's our new parabola. All right. We're going to take our formula y equals x minus h squared. I know that I'm just going to use the vertex again. Actually not. Let's use this one. Let's use the point 2, 1. All right, so I know that my y coordinate is 1 and my new x coordinate is 2. Okay, square root of both sides. The square root of 1 is 1. 2 minus h. Subtract 2 from each side. I get negative 1 equals negative h. Divide by negative 1 on each side. Negative 1 divided by itself is 1 equals h. Y equals x minus h squared. Y equals x minus 1 squared is our new formula. Again, I know that I need to take that point, this point over here, which was 1, 1, and now I need to make it 2, 1. Okay, well, how do I make them match up? If I subtract 1 from my x-coordinate of 2, I'm going to be doing the same thing I was doing originally. Right? The last one I want to show you a graph for is this one. Reflect y equals x squared over the x-axis. Okay, well that's simple. Okay, 0, 0 would stay where it is. 1, 1 goes down here to negative 1. And then I have 2, 4 goes over here to 2, negative 4. And the same thing on the other side. And it would look like this. This is probably the easiest transformation to write. y equals negative x squared. All we did was we took the original values and we changed them to their negative value. That's why the vertex at 0, 0 didn't move anywhere, because, well, you can't. There's no such thing as negative 0. Okay. By the way, I don't have to use a graph. I can use the function rule also. Vertex form of a quadratic is f of x equals a times x minus h quantity squared plus k. And just to remind you, now I'm going to show you something, and we're not going to use it too much for this practice. So if a is greater than 1, we're going to say that it is called we call it vertical stretch. If a is less than 1, we call it vertical compression. And that would have to mean a is greater than 0 as well. So if a is bigger than 1, it's going to be stretched. It's going to be kind of stretched out tall but thinner. If we have a between 0 and 1, a fraction between 0 and 1, it's going to be compression. It's going to be a little bit shorter and wider. If a is less than 0, that's going to be a reflect over the x-axis. Our h, we said, is going to be left-right, and our k is going to be up-down. Why don't we use v for vertical? Just because v can mean other things in math, so we take k instead, because k doesn't have any other meanings. Okay? Write an equation for a quadratic that has been moved up 3 units, left 2 units, and reflected over the x-axis. Okay, up 3 would be k is positive 3. Left 2 would be negative 2 for h. Okay? And then reflected over the x means a is less than 0. All right, they didn't tell me stretch or compression, so a is just 1, and it is negative 1, less than 0. X minus negative 2 for h, plus 3 for k, and simplify. F of x equals negative x plus 2 squared plus 3. All right? Let's do one more. Write an equation for the quadratic that has been moved down 2 units and right 4 units. Down 2 was k equals negative 2. Right 4 is h equals positive 4. We don't have any stretch, compression, or reflecting, so a is just positive 1. X minus 4 squared plus, and I can just leave that as minus, actually, 2. And that's it. Nothing else to simplify. All right? Last thing. This works for all functions. Absolute value of x, x to the third, x to the fourth, and any other powers of x, the square root of x, 1 over x, and on and on. We just usually teach it with x squared because that's one of the easier functions to work with. All right, thanks for watching this video on function transformations.